here's a preview of the circuit you're about to build. What we're going to do is write some code to actually blink both of these LEDs and actually get them to alternate blinks. So let's go ahead and get started. We're ready to expand this circuit to make it a little more interesting, and we're going to do that by adding another LED, another resistor, this is a 470 ohm, and some more wires. So basically what we're doing is we're building another one of these little connections here with an LED and a resistor connected to a GPIO pin. So we're going to use the very next pin in line, so going down from 17 we have 27 as the next GPIO pin. And I'm running this wire from what is row 9, that's where pin 27 is located, and I'm going to run this down from 27 on down to row 38. So again, pin 27 is in row 9, headed down to row 38. I'm going to span the ravine with a resistor. This is bridging both sides of row 38. And then I'm going to go ahead and add my LED. I want the anode, the longer leg, down towards the bottom here, and the cathode, the shorter leg, just one row above. So I'm going to put the anode in the same line as the resistor, that's row 38, and then row 37 is going to get the shorter leg, the cathode. So I put it at kind of a slant. As you can see, I have it sort of shifting both rows and columns there. And now I'm going to bring that back to the negative rail, creating our path to ground. This wire is going to jump from row 37 into the negative rail. Alright, so now I have two paths. One comes off of pin 17, goes down this wire, and through this LED on its way to ground, which we already know that we can control with some Python code. And this path comes off of pin 27, goes down this wire, through this LED, into the negative rail, and up to ground. So we can control now two LEDs with essentially the same kind of code. So let's go ahead and boot up our Pi and get started with programming. So go ahead and boot your Pi. Make sure that you have the T-cobbler plugged into the GPIO ribbon cable. You have your USB mouse and keyboard connected, your video cable connected, and your micro SD card inserted with your operating system installed. Add your power cord and it'll boot up. Remember that your username is Pi and your password is Raspberry. Use Start X to launch the desktop. Also remember to shut down your Pi before making changes to your circuit. You can use the shutdown icon on the desktop or use sudo halt from LX terminal. So I've booted my Pi, I've loaded the desktop, and I've opened up idle 3. Here we are at the Python shell, and I want to go and open the last project we did, blink17.py. Go ahead and open that up. Now the last time I was showing you blink17.py, I wanted to give you an illustration of an infinite loop. But we want to get rid of that and go back to the old for I in range 0, 5 that we had originally, because that was just a for loop that finished and actually allowed the program to reach GPIO.cleanup, whereas when we had that infinite loop, it was a fun demonstration, but it's not practical. So I'm actually going to go ahead and fix that about blink17.py and save that, and then I'm going to go ahead and start modifying this for our next project. So our next project is bringing in LED2, and the best way to get started here is to actually make LED2 its own variable. So LED2 is on pin 27, so I say LED2 equals 27. So now whenever I refer to LED2, I'm referring to the pin that it's connected to. I also need to make sure that it has its own GPIO.setup line, LED2 GPIO.out. So now LED2 is set up as a digital output. We're ready to actually refer to it to turn it on and off. So let's go on down to the old loop, which used to just turn on and off LED1, and let's add LED2 into the mix. Now, we can do this in a variety of ways, but what I really think is the most interesting way is to alternate them. So I want to put LED2 as false whenever LED1 is true. So LED1 will be on when LED2 is off. And then I want to put LED2 to true anytime LED1 is false. So what we have here is basically LED1 is on, then off, LED2 is off, then on, and it alternates. Let's go ahead and save this, but I want to give it a new file name, because no longer blink17. I want to choose save as, and we're going to call it alternate LEDs. Alright, so let's go ahead and save that. And now that we're ready, we can go ahead and open up LX Terminal. I'm going to actually kind of shortcut it here. I'm going to go to Accessories and open LX Terminal rather than going back to the desktop. If I do ls, I can see the folder contents. I can see alternate LEDs.py is in here. And I'm going to go ahead and say sudo python3 alternate LEDs.py. So let's go ahead and see what this does on our circuit. So as I hoped, we saw the LEDs alternate which one was lit, fitting to the name and accomplishing the task that we set out to do. But we can make this a little more interesting. So right now, what we have is basically when one is on, the other is off, and when one is off, the other is on. Good enough, and certainly is an accomplishment in its own right, because now we're controlling two LEDs, but it gets a lot more interesting whenever we consider how do we make this so that we have one LED that blinks every second and another LED that blinks every half second. So let's go ahead and modify this code a bit and make that work. So I'm actually going to do this in kind of a longhand way. In the next video I'll show you how to do it in a much quicker and more efficient way. So I actually am changing the time.sleeps down from 1 second to 0.5 seconds. And I'm actually going to just cleverly think about, hey, at the first half second break I want LED 2 to turn on. But I don't need LED 1 to change state because it's going to change every 1 second. So let's wait another half second. Now LED 1 can turn off, and LED 2, which was previously true, is now ready to turn off. So they kind of synchronize there for a half second. And I'm going to put another 0.5. Let's see here, LED 2 is ready to turn back on. And then wait one last half second. So if I've done this correctly, what we have here is some code that will make it so that LED 1 is on at the start, LED 2 is off, and then half second goes by, LED 2 turns on, LED 1 is still on, half second goes by, both lights turn off, so LED 2 is changing every half second, LED 1 is now changed after a full second, half second goes by, LED 2 turns back on, and then the remaining half second passes by, starting the loop over again. LED 1 turns on and LED 2 turns off. So we have LED 2 alternating every half second, LED 1 alternating every second. So let's see if I did this correctly. We're going to go ahead and say save, and head on over to LX Terminal and run the code again. Let's see what our circuit does. So our first LED alternated state from on to off and off to on every 1 second, while our second LED did it every half second. So we did in fact accomplish what we thought this code would do. Let's go ahead and take one last look here about how we can take this a little bit further. I'm just going to give you some ideas if you want to start playing around with this code. And I'm just going to leave it right here. I'm not going to make any changes, but I just want to inspire you with some ideas, because you can go back here and you can change these 0.5s to be other values. We try to get it so that LED 2 blinks every quarter second, while LED 1 maybe blinks every 3/4 second. You can change this in a variety of different ways, or really want to get ambitious, why not consider adding another variable? Why don't you add LED 3 and add another LED to your circuit? You could pick a variety of different GPIO pins that are still not used in this circuit yet. You just have to set LED 3 equal to whichever GPIO pin you wired it to. Make sure you protect that LED with a resistor, and you can set up a third LED and create 3 different LEDs blinking at 3 different rates, and do a variety of different changes to this circuit. There's a lot of potential for you to play around with this and get some new ideas, and I hope you enjoy watching this video and come up with some ideas of your own. Thank you for watching.